Thermal expansion. Thermal expansion means change in size, change in volume, change in length of an object due to rising temperature. Okay, so when heat is provided, things expand. Expansion is one of the effects of heat. Like heat causes change in the shape, heat causes change in color, heat causes rise in temperature. In the same way, heat causes things to expand. So here, this is a very common example we studied about already. We already studied about this thermometer. When it is heated up, the mercury level rises. Okay, because mercury expands and it shows the temperature. Like this is at lower temperature because 70 degrees Celsius, 140, and at higher temperature it expands more. Okay, so the greater the temperature, the more the expansion is. So all the things they expand, that expansion can be more or less depending on the type of the substance. So what is thermal expansion? Increase in size of any object like solid, liquid or gas on heating. The initial volume is of course smaller. On providing heat, it becomes bigger in size. It means there will be change in length, width, height, etc. in all. Okay, so this expansion depends upon the type of the substance. Like solids expand the least, liquid expands more than solid, and gases expands the most. Okay, so there will be greater expansion observed in gases. So when things expand, of course, volume increases, and volume increases, mass remains the same, means density decreases. Okay, because density is mass per unit volume, and when the mass changes, mass remains the same, volume increases, so density decreases. Rho is equal to mass over volume. Density is equal to mass upon volume. So expansion means greater volume. Volume is more. So when denominator increases, of course, the answer density will decrease. So what is the reason of thermal expansion? Actually, everything is made up of molecules. When heat is provided, the molecules, they don't get bigger in size. Remember, there will be no change in the size of molecules. Okay, but they will vibrate faster with the greater amplitude. Like they will move up to greater distance. So due to that, they will move further away. Slight distance between the molecules will change. So see that there are three molecules shown in this. So this vibration will cause the distance between the molecules slightly increase. So of course they will become bigger in size. Okay. In the same way, when things are cooled down, they will contract. And anything which expands more on heating, it contracts more on cooling. Which factor affect the thermal expansion? Yeah, of course, temperature is one of them. Okay, the higher the temperature, the greater will be the change in volume. So delta CT is the symbol used for temperature. So one of the things, change in the volume, change in the size, or change in the length, that all depends upon one of the factor, that is change in temperature. Okay, so we can say, suppose we talk about the length. When we talk only about the length, we call it linear expansion. And when we talk about the whole volume, we call it cubical expansion. Okay, so first let us talk about the change in length. So change in length is directly proportional to the change in temperature. Means change in length, delta represents change. Delta L is directly proportional to delta T. Change in greater increase in length is directly proportional to rise. Rise means change. So change in temperature. Okay, in the same way, that also depends upon the initial length and the type of the substance. quantified by the constant value for a coefficient of thermal expansion for some materials. Like we have specific heat capacity for the substances, in the same way we have the constant, that is for a substance, particular substance, we call it coefficient of thermal expansion. Okay, those things which expand more on heating, they have greater value of thermal expansion. Greater value of alpha. Alpha is the symbol for thermal coefficient of thermal expansion. Okay, so it shows how much rise in temperature takes place, how much change in length takes place for unit rise in temperature. Means alpha is the coefficient of thermal expansion. Greater the value of thermal coefficient of thermal expansion is, the greater will be the expansion. And in the same way, it depends upon the initial length, original length, how much longer material is, how much longer a rod is. Okay, if the initial length is greater, then change in length will also be greater. It means delta L is also directly proportional to initial length. L naught shows initial length at normal temperature. Greater the original dimension, greater the expansion. Initial length, initial volume. Okay, when we talk about increase in the area, we take initial area. If we talk about the linear expansion, change in length, lengthwise expansion, we take L. Otherwise, for volume, we'll take V. But in O levels, we only talk about the linear expansion. That is change in length due to rise in temperature. So our equation becomes delta L, change in length, change in dimension, is equal to alpha, that is coefficient of thermal expansion, L naught into original length and into delta T. If these factors are greater for a substance, greater rise in temperature, greater original length, and greater value of alpha, the greater will be the value of change in length. Okay, so here are some values for the thermal expansion. You can see aluminium, coefficient of linear expansion for them, and this is coefficient of volume expansion. If we talk about change in total volume, we will take these values, but for the change in length, we take these values. So you don't need to memorize these tables, and these values can be taken from the table. Okay, so brass, which one expands the most on heating? If you see the table here, and this lead expands the most because its coefficient of thermal expansion is greater, 2.9 into 10 to the power minus 5 per degree rise in temperature. Okay, so this lead 1 meter longer, what this coefficient of thermal expansion, linear expansion say? What is change in length per unit length per degree rise in temperature? Okay, how much longer 1 meter longer rod of these materials will become for 1 degree rise in temperature? Okay, so when you take 1 meter, all the rods are of the same length. Of course, for the fair test, initial length of all of them is suppose 1 meter. Okay, so when we heat them up by 1 degree Celsius, so that will be this much extra long, 2.2 into 10 to the power minus 5 meter longer than its initial length. So its new length will become what? For aluminium, it will become 1 meter plus 2.2 into 10 to the power minus 5. So that will be new total length. That expansion is very minor, not noticeable. That is why we don't observe this expansion in our daily life. Okay, it's not seen. But for greater rise in temperature, we do observe it. And we have effect of these thermal expansion in our daily life examples. Okay, we'll just see those examples little later. Here this is the concrete, lead, See all these things. Mercury I've already told about the mercury. Water we will study later on. Air is gas, so it expands the most. Okay, water also has greater thermal expansion, linear expansion or thermal cubical expansion, because in these substances, liquid and gases, we talk about volume. We don't talk about only length. But for solids, when the only rod is considered, we can talk about their length only. Here. So this is initial length, and how much extra it has become? This much extra on heating. So for rise in temperature. The new length is L plus, this is change in length. Means if this is initial length, okay, on heating it will become bigger and its new length is slightly greater. Okay, so this is delta L. This length is delta L. And this is L naught. So what is new length? New length, we may call it L1. L1 will be what? L naught plus delta L. Okay. So for greater rising temperature, this delta L will be greater. Okay. Now, if you have initial length more than this, if you have already longer rod, okay, the length is twice. 1 meter expands, suppose by 0.00001 meter, for example. So if initial length is 2 meter, then what will be extra length? That will be for each meter will expand this much. So 2 meter longer rod will be expanding by 2 meter. 3 meter longer rod, each meter will expand this much. Means 0.00001 plus 0.00001 plus 0.00001 means 3 meter longer rod will be having this extra length. So what will be new length? 3 plus 0.0003 means 3.0003. So that is why this expansion is very small, that we don't notice it when the rise in temperature is small. That they all are considered for 1 degree rise in temperature. For 2 degree rise in temperature, what will happen? 1 meter longer rod will be this much, 2 meter longer rod will be this much, and 3 meter longer rod, 3 to the 6. Okay, so that again depends upon not only initial length, it depends upon the temperature also. So the formula which we studied just in the previous one, delta L. So if I bring L naught to the other side, I get this delta L upon L naught equals to alpha delta T. Okay, the equations, the questions usually they are not, numericals are not usually asked, but you need to know the expansivity. Which one has greater expansivity? The table of values will be given to you, and you may be asked to compare. Okay, so this is coefficient of linear expansion. These are the values we already seen. This is cubical expansion, change in volume. This we are not going to study. And now some real examples of this. This spelling of some is written wrong here. Okay, there is, wait a minute, I need to change this. The electrical cables are loosely fixed to the electric poles so as when during hot weather the conductor will expand and cable will not cut down. Okay, in the same way they should not be too short also, because if they are shorter during the winters they will contract. When they will contract, they will become smaller in size and they may break. So it means little loose space is to be left. In the same way, there are gaps left between them. These are the iron railings which are present on the road. Okay, so the gaps are there so that when they expand, they will become bigger in size and they will fill up the gap and they won't be crooked. Okay, they won't lose the shape. Kitchen example, I can't get this metal lid off. the jar. So what should we do? We can heat it up. We can use a cloth to rub against, okay, so that it expands due to that heat. Okay, this is the opening of the jar. We can do it by heating up. We can pour hot water also. This is also the solution. There are sums on the thermal expansion. Okay, so what are the sums here? The question: calculate the increase in length of the brass rod, which measures initial length is 220 centimeter at 0 degrees Celsius, such that it is heated to 950 degrees Celsius. So what is the change in temperature from 0 to 950? 950 minus 0 is, initial length is 10. It's not 0, it's at 10 degrees Celsius. So what is the change in temperature? 950 minus 10 is 940. Okay, so this is the value of expansivity given for the brass, 0.000018 per degree rise in temperature. So calculate the overall length at 950 degrees Celsius. So initial length 220 meters. Here it is written centimeter, but it's meter. Okay, so we will take this length and alpha value is substituted and change in temperature is substituted. So what is the increase in length? Delta L is 3.272 centimeter. So what will be, this is, here it is wrong, 220 centimeter this is. So new length is 220 plus 3.72 centimeter. Okay, this is centimeter, not meter. Another example, 2 meter long, a brass rod heated to 80 degrees Celsius, increase in length by 3.2 millimeter. Now, millimeter is to be converted into meter because this is given in meter. Calculate the coefficient of linear expansion. Of course, you won't be asked to calculate these kind of questions, but anyhow, this will improve your understanding. So we have the formula alpha is equal to delta L upon L naught into rise in temperature. So when we substitute these values, we get this answer of coefficient of thermal expansion. Why is it advisable to allow telephone lines to sag when stringing them between the pokes in summer? Okay, so sagging is allowed so that when they contract in winter, so they will be of proper size. Applications of thermal expansion in solids we are talking about. So one of the very common example is bimetallic strip. Okay, bimetallic strip is made up of two metals which have different values of alpha. One is having greater value of alpha and the other one is having smaller value of alpha. Okay, one expands more on heating and the other one expands less on heating. Means this is one rod, I can take another rod of different expansivity. So brass and invar, they may be the common example. They are joined this way. They are of the same initial length, but their types are different. One has greater value of alpha, means that will expand. Greater value of alpha means it will expand more on heating. Alpha greater, more expansion for same rise in temperature. Okay, so suppose this is brass and this is suppose iron or invar. So brass has greater expansivity. So when we join from end to end, it means it cannot become longer like this on heating. Brass, of course, tends to become longer, but this will not happen. It will grow. No, it won't be allowed because this is tightly welded here. We weld them tightly from end to end. It means no allowance for expansion is given here. So what will happen? It tends to become bigger in size, more bigger than iron. So it applies greater force and on heating it becomes like this. It will bend It will be curved like this. Both will curve because brass will apply force on this in var or iron. Okay, so this is brass. Which one is bigger? Of course, the one which is on the outer side of the curve. So brass expands more on heating than iron or in var because alpha value of alpha for the brass is greater. Okay, so this becomes like this, and it has so many uses. And one of the uses is in the bimetallic thermometer, and one of the other uses thermostat, which is in the electric iron. Okay, we use this bimetallic strip in thermostats. Thermostat is one major part in electric iron. Okay, that will cause automatic turning on and off of the uh, iron, electric iron. Okay, so how does it function? And one thing more. Brass expands more on heating and it is on the outer side. Suppose I will color it. Okay, so on this one is this brass. Okay, but when we cool it, on cooling, what will happen? Reverse will happen. Brass will become shorter than in var and it will be on the inner side. It will be shorter. So the one which is shorter, that will be on the inner side. And this is brass on cooling. Okay, and this is heating. It becomes bigger, expands more, and it's always on the outer side. So we have the example of this thermostat. One example I'll explain you now, and other example we'll study later. This is a simple circuit, and this is a contact. This is battery. Okay, this is battery, and this is alarm. Right now, alarm is not sounding. Okay, because there is contact is not made. They are not joined. Okay, for the circuit to be complete, this is alarm. It's not sounding. Battery is there, but it's not sounding because there is a gap between the two contacts. Okay, so what happens when there is fire around? This will be heated up, and what will happen? This will become curved. What will be the new situation? It has become curved. This is your brass on the outer side. Okay, and the contact has come closer to this and it is joined due to bending. This bends. Okay, the whole bimetallic strip means bimetallic means two metals of different expansivity. This has become bigger. So this is on the outer side. So now contacts are made. Now there is a complete circuit. So the current flows and alarm sounds. So that can be simple fire alarm. In the same way, we can see this, we can use this thermostat in the electric iron. So use of the thermostat in electric iron we will study later, but here I will explain one more example of this thermal expansion, the bridge. Suppose this is the bridge, okay, and these are the walls of the bridge. Vehicles, they go around. Okay, so they are laid on rollers. So there is a gap, we leave some gap for the expansion, and we, in order to allow for the expansion so that they become bigger in size, we put rollers at the bottom. Okay, so that they can move easily on those rollers, and when they grow in length, they will fill up this gap. There will be slight. Not on both the sides. On one side they will be laid on the roller, other side they will be directly on this. These are the rollers which will allow them to move. Like rolling action, it always makes the movement easy. So what will happen during summers when the bridge becomes bigger in length? So this gap is filled in due to increase in the length. So this will go forward and fill up the gap. So that will not cause the bridges to sag. Otherwise, they will become like this, and they may break also due to their own weight. Okay, so the gaps are left in the bridges, and they are laid on rollers to allow for the movement during expansion. Okay, in the same way, railway sections are also having gaps. Okay, we have gaps in the railway tracks also, so that when they expand, these gaps are filled in, and when they contract, they will come back to normal size. All how much gap is to be left, these all are done by calculating using that equation which I told, delta L equals to is equal to L naught alpha delta T. Using this equation, what will be the rise in temperature, what is the value of alpha, that material, concrete, okay, and what is initial length, and how much longer it may become due to that rise in temperature is calculated, and according to that length the gaps are left. There should not be too much longer bigger gap, not too much smaller gap. Okay, so they are laid, they are left, the gaps are left after doing the calculations. Okay, so after this we will have to study about the applications of bimetallic strip. One application I just explained, simple example, and we will study more complicated example, use of bimetallic strip in the thermostat of electric iron. That also is to be studied. Here this is bimetallic thermometer, this is the pointer. So when this expands, it uncoils. When it uncoils, because there are two metals, okay, there's, you can see the two slightly different colors here. So one is the iron strip and the other one is brass strip. So this will slightly uncoil, and the pointer, it will move forward. Okay, so how much uncoiling will take place, or coiling, it may coil more or it may coil less. Okay, it may uncoil or coil depending on increase or decrease in temperature. So we can measure the temperature using this bimetallic thermometer also. That means thermometer is not only made up of this resistance thermometer or thermocouple, we can have bimetallic thermometer as well. Okay, then after this thermostats in the electric iron, we have to study about the thermal expansion in water. Okay, so that's all for today, and let us now stop, watch this video, don't understand anything, ask in the class.